Okay, I'm right. Thank you. Good morning, friends. Welcome back to the next class of mathematics for GATE preparing aspiring students. So yesterday we were in the middle of first order, first degree ordinary differential equations. So this is what all we have done briefly. First order, first degree equations. We have considered variable separable method, and then classification of these first order, first degree equations, variable separable method. Second one is linear equations. We have done some problems on this, and then we have seen Bernoulli's equation. Then equations reducible to Bernoulli form, exact differential equations. We are dealing with now exact differential equations, and a couple of methods we have completed in this. But anyhow, just once again go back to the conditions for exactness once, just so that we have 2-3 more methods to do. If you know these methods once again, recap these things once again, it will be easy for us. So let mdx plus ndy is equal to 0 is first order, first degree equation. This is called exact differential equation if there is a function such that dou f by dou x is equal to m, dou f by dou y is equal to n. And condition for checking this equation, whether this equation is exact or not, the testing condition is dou m by dou y is equal to dou n by dou x. Here m and n are real valued functions having continuous partial derivatives. If it does not satisfy, then these things, they don't have any meaning. The necessary sufficient conditions are dou m by dou y is equal to dou n by dou x. By saying necessary and sufficient condition mean that whenever this condition is satisfied, the equation is exact, and whenever this equation is exact, this condition dou m by dou y will be satisfied. So this is what we mean by this necessary and sufficient condition. I will open this so that you can understand. You can look at this cursor. Okay. Yeah. So then, if the equation is exact, then the solution is given by integral over m dx, assuming y as constant, plus integral of n which are independent of x, the terms not containing x in n with respect to dy is equal to constant. This is the solution whenever this equation is exact. So question now, if it is exact equation, then what is the no problem, then we can find a solution. If this equation is not exact, what happens? So questions in this method may be like this. Say for example, here a problem is given m square minus 2xy dx plus 2xy minus x square. So the problem may be here like this. So you will be given equation like y square minus 2xy plus dx plus 2x minus x square dy. Question is, alternatives will be given to you. The equation is A, exact, B, non-exact, C, linear, D, none of the above. So for that you have to check each and every of these things. So first check dou m by dou y is equal to dou n by dou x. If it is exact equation, it is exact. If you don't, they are not equal, you have to select the option not exact. So say for example, sometimes the problem in this case is an exact equation. So the problem may be like this. What I am saying to you is, here if you look at this problem, you say you may think that is lengthy problem, but in the examination this problem can be divided into a part of this problem may be asked as a question, like this equation is A exact, B not exact, C linear, unhomogeneous, something. Maybe the problem may be the given equation y square plus 2x by dx plus 2x minus x square dy, if it is exact, what is the solution? So it is given as exact. You need not verify the condition for exactness. Okay. What I have to do is then find a solution. So the same problem can be asked in three different ways. You may be asked to find a solution, or you may be asked to test the exactness of the differential equation. If it is given as exact, you may be asked to find the solution. So all the three steps you have to prepare. Okay. So next thing is, when the equation is not exact equation, what can we do? Can we reduce it to exact form or not? So this is, we have seen these formulae, and then we have done some problems also on this. And then this one is mdx plus ndy is equal to 0 is not exact, but homogeneous. That means m and n are the same degree. Then if mx plus ny is not equal to 0, then 1 by mx plus ny is an integrating factor of mdx plus ndy is equal to 0. This is the result we have. So y square dx plus x square minus xy minus y square dy. I think this problem we have done yesterday. So this also we have done yesterday. So the third condition is mdx plus ndy. This also we have done yesterday. Is not exact, but in the form y into f of x into y dx plus x into g of xy dy is equal to 0. Then if mx minus ny is not equal to 0, then 1 by mx minus ny is an integrating factor. Okay. So case 5, case 4. Yes, this is we have to start today. If mdx plus ndy is equal to 0 is not an exact differential equation, but if dou m by dou y minus dou n by dou x by n is a function of x alone, that means there should not be any terms of y in this fx. I repeat, dou m by dou y minus dou n by dou x by n is a function of x alone, then e power integral f of x dx is an integrating factor. This is the result. So example, 3xy minus 2ay square dx plus x square minus 2axy dy is equal to 0. Because my is 3x, dou m by dou y is, this is m, no? Dou m by dou y is 3x minus 4ay, and this is n, dou n by dou x is 2x minus 2ay. So clearly dou m by dou y is not equal to dou n by dou x, but you can observe that dou m by dou y minus dou n by dou x by n is 3x minus 4ay minus 2x minus 2ay minus of minus 2ay. So it will be x minus 2ay by m is, if you take y common, this will be n. If you take x common, x minus 2ay. So this x minus 2ay can be cancelled. So you will be getting 1 by x, which is a function of x alone. So then e power integral f of x dx is integrating factor. So e power integral 1 by x dx is e power log x, that's same as x. So multiply the equation with x, 3x square y minus 2axy square dx plus x cube minus 2ax square y dy is equal to 0. This is a new equation after multiplying with the integrating factor. So let us check it whether the new equation is exact or not, purpose is served or not. So this is your new m now. Dou m by dou y is 3x square minus 4ayx, and this is n now. Dou n by dou x is 3x square minus 4axy. So clearly dou m by dou y is equal to dou n by dou x. So the given now the new differential equation is exact. So the exact equation solution is integral m dx assuming y as constant plus terms independent of x in n, integral of that with respect to y. So we observe this is x cube and this is x square. Both the terms are having x. So there is nothing here which is independent of x. So integral 0 dy. So if you integrate this, x cube y minus ay square x square is equal to constant. This is. So another example, x cube minus 2y square dx plus 2xy dy is equal to 0. M is x, this is n. So dou m by dou y is minus 4ay minus 4y, and dou n by dou x is 2y. They are not equal, not exact. So my minus nx by n. My is minus 4y, nx is minus 2y. So my minus nx is minus 6y, by n is 2xy. If you cancel y, you will get minus 3 by x, which is a function of x alone. So integrand factor is e power integral f of x dx, e power minus 3 integral 1 by x dx. This is minus 3 log x, or e power log 1 by x cube, or simply 1 by x cube. If you multiply this equation with 1 by x cube, so this is what we get. Or else 1 minus 2y square by x cube plus 2x power minus 2y dy. So integral over m dx, assuming y as constant, plus terms independent of n, integral of terms independent of x in n with respect to y. So we don't have any terms here independent of x. We have only one term that is having x here. So if you integrate this is what we get. So the same question now, as said, the same question can be, if you look at the solution now, people saying that it's a lengthy question, how can we answer this in the GATE examination? So the question is not why we do such problems, big problems is, if you do such big problems, you can answer 3 types of questions, 3 or 4 types of questions. That's what I am saying. The same question can be maybe asked directly, or else it can be divided, a part of this question may be asked in the examination. Part of this question means, let us see the same problem, how it can be asked. Let's say the previous problem I have taken, or some other new problem, whatever it is. So the equation, now I have taken an equation, y into x square plus y square plus 2 dx plus x into 2 minus 2x square y square dy is equal to 0. Is A exact, B homogeneous, C not exact, D linear. Okay. So the first part, we are actually in this type of problems, what we are doing, first we are checking for exactness, whether it is exact or not. How? Dou m by dou y is equal to dou m by dou x. If it is equal, we are saying exact, otherwise not equal. That can be asked as a small problem. So first you have to check this, whether they are equal or not. If they are equal, yes, the option is A. If they are not equal, not exact. Okay. If exact, you may be asked to find the solution. Your 4 options will be given to you. You have to integrate them like this: integral of m dx plus integral of terms independent of x in n with respect to y. That step we have to do here. So that is another small question that can be asked from this problem. If it is not exact, if it is exact, directly we get solution may be asked. If it is not exact, that means if the same equation is given, it is given that it is not exact. The equation y into x square plus so on and so forth is not exact. Then what is integrating factor, which converts non-exact equation into exact equation. Then you have to see what is the type of problem we have. M, the degree of M, we have discussed 3 methods already. Inspection method, homogeneous, if M and R homogeneous of the same degree, then mx plus ny not equal to 1 by mx plus ny, but they are not homogeneous. Then 1 by mx minus ny, check it. Otherwise, you have to apply the present method. This is dou m by dou y minus dou n by dou x by n. And that means you have to check what sort of equation it is. Whether it comes under first type equation, or maybe it's homogeneous equation, or dou m by dou y minus dou n by dou x by n, so on and so forth. Then find the integrating factor. That is also one type of question. The equation is given as not exact. Then you may be asked to find the integrating factor. Very good. So you find it. That's also over. And then still, if the integrating for the non-exact equation, it is given as non-exact equation, the integrating factor also is giving. So if the integrating factor for the non-exact equation, so on and so forth, is so and so, then what is the solution? Then what you have to do? You have to multiply the given differential equation with this integrating factor. Resulting equation will be exact. Then find the solution of the exact differential equation into n dx plus n dy. plus integral terms independent of x and en with respect to dy is equal to c. So how many questions can be asked from this some same problem? 1, 2, 3, 4. There are 4 sub-problems. Mind you, there are 4 sub-problems in each problem. Some 4 possible questions from each problem. Okay, so that's why if you practice these problems completely as we have been doing, then you can ask any of these 4 questions easily. Okay, so don't think that the questions are very lengthy and all that. You may have a part of the question as a main question. So the last method here, case 5, for dou n by dou x minus dou m by dou y divided by m is equal to g of y, function of y alone, no terms of x, then e power integral g of y dy is an integrating factor. So solution, example, find the integrating factor for y power 4 plus 2y dx plus xy cube plus 2y power 4 minus 4x dy is equal to 0. As usual, this is your m, this is your n. Then dou m by dou y is 4y cube plus 2 and dou m by dou x is y cube minus 4. Okay, so are they equal? No, so not exact. And what is nx minus n by my? N is y cube minus 4 minus 4y cube minus 2 by m is this one, y into y cube plus 2. So if you simplify the numerator, we will get minus 3 into y cube plus 2 by y into y cube plus 2. If you cancel y cube plus 2, you will be left with minus 3 by y, which is a function of y alone. Okay, so integrating factor is, if you call this as g of I, integrating factor is e power integral g of y dy. So this is 1 by y cube. Find integrating factor if the equation so and so forth y into x plus y plus 1 dx plus x into x plus 3y plus 2 dy is not exact. So my is x plus 2y plus 1. If you want, you can check it because it's already given in the problem. If the equation is not exact, you need not check it. But anyhow, just for your sake, I am writing how to check this exactness of a differential equation. So dou n by dou x minus dou m by dou y by m is dou n by dou x is 2x plus 3y plus 2 and dou m by dou y is x plus 2y plus 1. So minus of that by m is y into x plus y plus 1. So if you simplify this, 2x minus x, 3y plus 2, 3y minus 2 by y plus 1, x plus y plus 1 by y into x plus y plus 1. So this is a function of y alone, 1 by y. So integrating factor is e power integral g of y dy, that is e power integral 1 by y dy. So it comes out to be e power log y r y. So as usual, as I said earlier, the same problem can be asked in different 4 different parts. It can be divided into 4 different parts. The equation y power 4, the same problem I have taken here. Okay, then how this can be asked? Y power 4 plus 2y dx plus xy cube plus 2y power 4 minus 4x dy is not exact, homogeneous, higher order. Let us check. Not exact and exact, you have checked. What about other options? Is it homogeneous? No. Why? It is degree of x is 1, y is 3, so 1 plus 3, 4. Here it is 4, but here it is x power 1 only. Here also it is 4, degree of y is 4. Here y power 1. So it's not homogeneous equation. It's not higher order equation. It is only first order differential equation. Dy by dx, highest derivative is dy by dx. It is only a first order equation. So clearly C and D are not correct. So the answer must be from these 2 options A and B. For that you have to check dou m by dou y, dou n by dou x. Dou m by dou y is 4y cube plus 2. Dou n by dou x is y cube minus 4. Clearly they are not equal. So the given equation is not exact. Option is A. Because it is not exact, they cannot ask you a question directly what is the solution of the equation. Okay. So the same question now, the equation so and so, whatever it is here, is not exact. And what is integrating factor? What is integrating factor? For that, what you have to do? Nx minus my by m. So nx is y cube minus 4 minus 4y cube minus 2 by y into y cube plus 1. This is minus 3 by y. That is, if you call it as g of y. So integrating factor is e power integral g of y dy, or else e power 1 by y cube, or so 1 by y cube. So integral factor, whatever option is there here out of a, b, c, d, the answer is 1 by y cube. You can answer the question. Another part of this question is, now it is given as not exact equation, and it is also given the integrating factor. If the integrating factor for so and so problem is, as I said, is 1 by y cube, then what is the solution? So when integrating factor is known, what we do? We multiply the given equation with 1 by y cube, integrating factor. So this is the equation, resulting equation. So integral m dx, so everything is y, so x into y plus 2 by y cube. Integral of terms independent of x in m with respect to y. So this is x, we have, in this we have x, so only term independent of x is 2y. So the integral of this with respect to y is y square. So like that, this problem can be divided into different parts, A, B, C, and any of these parts can be given as a question for you. So with this, we have come to an end of first order, first degree, ordinary differential equations, and we will see more problems like this. So we consolidate now whatever we have done till now, all those 5, 6 or 7 methods we have done, and I will ask explain you some problems on all these methods together. One is variable separable method. The first problem is dy by dx is equal to x into 2 log x plus 1 by sin y plus y cos y. Clearly, the numerator is a function of x, denominator is a function of y. So it is a clear-cut case of variable separable form. So dy by dx is equal to, so if you cross multiply this, sin y plus y cos y dy is equal to x into 2 log x plus 1 dx. Integrating both sides, integral of sin y plus y cos y dy plus integral x into 2 log x plus 1 dx plus c. So sin y integral is minus cos y sin y minus, using by parts here, cos y integral is sin y minus 1 into cos y integral sin y. And the next step is equal to 2 log x into x plus x dx. So this is all by parts, minus cos y plus y sin y, and sin y integral is minus cos y. So this is how it happens. So cos y gets cancelled. So y sin y is equal to 2 log x square by 2 minus integral x dx x square by 2 plus c. So this is the solution for the given problem. So next one is, sometimes you don't get it, x plus 1 dy by dx is equal to x into y square plus 1. Here also you can separate this terms of x and terms of y clearly. So x plus 1 into dy is equal to x into y square plus 1 dx. So send this x to this side, then and y square plus 1 to this side and x plus 1 to this side. So what happens is dy by y square plus 1 is equal to x dx by x plus 1. So on integrating, 1 by 1 plus y square dy is equal to 1 minus 1 by x plus 1 dx. So 1 by 1 plus y square, the integral of that is tan inverse y is equal to, this is x minus log 1 plus x plus c. So try it. We have xy square plus x into dx plus yx square plus y into dy. You can take x common here in the first term and y in the second term. So y square plus 1 into x dx minus y into x square plus 1y dy. So y by y square plus 1 is equal to x by x square plus 1 dx. So if we integrate this, This is log y square plus 1. This is minus 1 by 2 log x square plus 1 plus c or log c. Then you can simplify this. Y square plus 1 into x square plus 1 is equal to constant. Find the solution of the differential equation dy by dx minus x tan y minus x is equal to 1. Sometimes see here why this example is very typical is tan of y minus x. You cannot directly pull out this x or y out of this tan function. Okay. So in such case, what we can do is you assume this is y minus x is equal to some t. Y minus x is equal to some t. So that becomes simply tan t. So if you put y minus x is equal to t, so that dy by dx, integrate with respect to x throughout, this is dy by dx and derivative of x with respect to x is 1 is equal to dt by dx. That means you can change this equation now completely into t. So dy by dx is 1 plus dt by dx. So 1 plus dt by dx minus x tan t is equal to 1. Or dt by dx, you can cancel this 1 both sides. This one and this one. So dt by dx is equal to x tan t. Or dt by tan t is equal to x dx. Or cot t dt is equal to x dx. If you integrate, integral of cot t dt is log sin t and this is x square by 2. Or substitute this t is equal to y minus x at the end. This is what we get. Next one is linear equations. X into x minus 1 dy by dx is equal minus x minus 2 into y is equal to x square by 2x minus 1. So I told you while dealing with linear equations, first thing that you have to do is we have to make this dy by dx coefficient equal to 1. Make the coefficient of dy by dx equal to 1. For that, divide throughout by x into x minus 1. So dy by dx minus x minus 2 by x into x minus 1 y is equal to x square into 2x minus 1 by x into x minus 1. So this is clearly in the formula dy by dx plus p of x into y is equal to p of x. So the integrating factor is e power integral p of x dx. So integrating factor is e power, this is p of x minus x minus 2y x into x minus 1. So this you can split into partial fractions, 1 by x minus 1 minus 2 by x. Okay. So we get integrating factor. We multiply throughout this with I think there is a mistake in this. There's a mistake we have to. I'll check it. Okay. And the solution, multiply the equation with throughout the equation with integrating factor and then integrate, find the solution is what we get. So next one is dy by dx plus 2 by tan x is equal to sin x. Sometimes a condition may be given like this, initial condition. This is what we call initial condition, initial value problem. Then find the maximum value of y of x. Dy by dx plus 2y tan x is equal to x. In the form dy by dx plus p of x into y. Here p of x is 2 tan x. So integrating factor is e power integral 2 tan x dx. Same as tan x integral log secant x. So this 2 can be taken like this. So e power log secant square x or integral factor is secant square x. And the solution is y into integrating factor is equal to integral of q into integrating factor plus c. This is what we have, the formula for linear equations. So y into secant square x is equal to integral of q of x, that is sin x, into integrating factor. So this is same as secant x tan x. So whose integral is equal to secant x plus c. So the solution is y is equal to secant square. Y secant square x is equal to secant x plus c. What is next? And y at pi by 3 is equal to 0. So we have to use this y at pi by 3 is equal to 0 to evaluate this constant c. Okay. So if you put x is equal to pi by 3 in the given equation, secant square, and at that y is equal to pi by 3, y is 0. So y becomes 0, this left hand term becomes 0, is equal to secant pi by 3 plus c. But secant pi by 3 is 2, so c becomes minus 2. So your solution will be y secant square x is equal to secant x minus 2 if you substitute this here. Okay, is like this. And the question is further extended. Find the maximum value of y of x. So till now what we have got obtained is y. For the maximum or minimum, what happens? We first find the first derivative of this equation equal to 0. So your dy by dx is minus sin x plus 4 cos x sin x equal to 0. Sin x is 0 or cos x is 1 by 4. And then find a second derivative. Whenever this y second derivative is less than 0, we have maximum at that point, and it is greater than 0, we have minimum at the point. So using that argument, we can find the maximum value of this f of x or the solution. So next problem is y square dy plus y into x plus y dx. So x square dy plus y into x plus y dx is equal to 0. So here also we have what this can be converted into dy by dx plus y by x is equal to minus y square by x square. This is almost it appears like a Bernoulli's equation. It is, in fact, it is a Bernoulli's equation because we have y power n here. It is a Bernoulli's equation, y power n. So what do we do in this case? Divide throughout by y square. So 1 by y square dy by dx plus 1 by xy is equal to minus 1 by x square dx. If you put 1 by y is equal to 0, then 1 by y square dy by dx is dz by dx. So this becomes, this 1 by y square dy by dx, it becomes dz by dx. 1 by y is minus z by x is equal to minus 1 by x square. So it's in the form, linear form, so wherein p of x is minus 1 by x. So this becomes e power minus log x or 1 by x. So multiply this equation with 1 by x, z into 1 by x minus 1 by x, z into 1 by x, okay, minus z by x square is equal to minus 1 by x cube. Yes, if we integrate this, we get a solution like this. Next one is secant x tan y is equal to e power minus x dx plus secant x secant square y dy is equal to 0. So this also very smoothly can be converted into linear equation. We have secant x tan y minus e power x plus secant x secant square dy by dx. That can be simply, so this is a bit more complicated terms we have. So you have to be very careful while dealing with these problems in converting into linear form. Okay. Go through this problem, you can understand easily. Now solve the differential equation dy by dx plus 2x by 1 plus x square y is equal to 1 plus x square whole square, given that y is equal to 0 when x is equal to 1. So this is the given differential equation where p of x is 2x by 1 plus x square and q of x is 1 by x square plus a whole square. So integrating factor is given by e power integral p dx, integral 2x by 1 plus x square, e power integral log 1 plus x square, e power log 1 plus x square is 1 plus x square. So the general solution is y into integrating factor is equal to integral q into integrating factor dx. So y into integrating factor is y into 1 plus x square, integral q into, q means 1 by x square plus whole square, 1 by 1 plus x square whole square into integrating factor is 1 plus x square dx. So this term and this one gets cancelled. So then becomes integral over c 1 by 1 plus x square dx plus c, this is tan inverse x. So this is the equation, but condition is given to you when x is equal to 1, y is equal to 0. So if you put that x is equal to 1, then y becomes 0. So 0 into this thing is 0. tan inverse 1 plus c. Tan inverse 1 is pi by 4. So 0 is equal to tan inverse 1 plus c, or c is equal to minus tan inverse 1 or minus pi by 4. So put this condition here in this equation 2. So y into 1 plus x square is equal to tan inverse x minus pi by 4. Coming to the exact and non-exact differential equations. So clearly the first method is, I told you, and you have to remember those formulae very clearly, method of inspection. If you see the term like this, and the term here. So from this you can straight away write this actually. You can straight away write this actually. Do you remember those formulas? Shall I have to tell? Okay, once let us see. What are the formulae we have? Yes. What is tan inverse x by y? Derivative of tan inverse y by x by tan inverse x by y is y dx minus x dy by x square plus y square. So if you see this now, x dx plus y dy is 2x plus, if you multiply with 2 and divide with 2, 1 by 2 into 2x dx plus 2y dy is 1 by 2 x square plus y square. This is tan inverse x by y. Directly you can get. Otherwise you can use exactness also. How, whether it is a test the exact equation, whether it is exact equation or not, and find the solution. That way also you can do it. Either way. Next one is 1 plus e power x by y dx plus e power x by y into 1 minus x by y dy. So dou m by dou y is so and so, dou m by dou x is so and so. So dou m by dou y is equal to dou n by dou x, therefore the given equation is exact. So integral m dx plus integral terms independent of x in this, there are no terms. You have 0 here. So integral 1 plus e power x by y dx is equal to c. That's what you get. Next, solve 2x log x minus xy dy plus 2y dx. So instead of trying whether it is linear form, that form or this form, straight away you can go for exact verification for exact differential equations. So dou m by dou y clearly is, this is m and this is n. So dou m by dou y is 2 and dou n by dou x is 2 into log x. Okay, x log x. X into log x derivative is 1 by x plus log x. So that's what we get here. Clearly they are not equal. That means the equation is not exact. So dou m by dou y minus dou n by dou x. If 2 here gets cancelled. So minus 2 log x plus y by, you take x common, 2 log x minus y. So this is minus 1 by x, which is a function of x alone. So integrating factor is e power integral f of x dx or e power integral minus 1 by x dx. So e power minus log x or log 1 by x, the same as 1 by x. And multiplying the equation with 1 by x, the integrating factor, this is what we get. So this will be exact. Assuming it is an exact now, we get the solution integral m dx plus integral terms independent of x in n with respect to y. So we get the solution. So next one is y power 4 plus 2y dx plus xy cube plus 2y power 4 minus 4x dy is equal to 0. So here m is equal to y power 4 plus 2y, n is xy cube plus 2y power 4 minus 4x. So dou n by dou y is by 4y cube plus 2, dou n by dou x is y cube minus 4. So dou n by dou x minus dou n by dou y by m is minus 3 by 5. Our integral factor is e power integral f of y dy. So that becomes e power minus 3 log y or 1 by y cube. So integral 2y dy. So this is the solution that we get. Okay. The next problem is solve y square dx plus x square minus xy minus y square dy is equal to 0. The given differential equation is so and so. M is y square, n is equal to x square minus xy minus y square. Dou m by dou y is 2y, and dou n by dou x is 2x minus y. So that dou m by dou y is not equal to dou n by dou x. So the given equation is not exact, but it is, see, if you see the terms here, it's y square degree 2, and here x square degree is 2, x into y, degree is 1, total is degree is 2, and here it is again y square degree is 2. So that means the equation is not exact, but it is homogeneous equation. When this equation is homogeneous and not exact, and if mx plus ny is not equal to 0, there is method 2 in exact equations. So then 1 by mx plus ny becomes the integrating factor. So 1 by mx plus ny is x square, x into y square into y into n. So some other terms gets cancelled. So this is what we get, y into x square minus y square. Multiplying equation, given equation with 1 by y into x square minus y square, we get it like this. So this obviously will be the exact equation, because why? Because we have multiplied the equation with already integrating factor. It has to be exact. Now into our m dx, if you want you can check it. M1 is y by x square minus y square, n is so and so. So check dou m1 by dou y and dou n1 by dou x. They are exactly equal. Hence the equation is exact differential equation. So the solution becomes integral m dx plus integral n into dy. Okay. So if you integrate carefully, you get this solution. Log x minus y by x plus y under root y is equal to c. This is what we get. Next problem. Solve dy by dx is equal to x square plus y square by xy. We have x square plus y square minus dx minus xy dy is equal to 0. M is so and so, n is minus xy. So mx plus ny, dou m by dou y is 2y, dou n by dou x is minus y. They are not equal, and the degree is 2 here, degree is 2 here, degree is 1 plus 1 2 here. So homogeneous equation. So mx plus ny is not equal to 0, 1 by x cube. So integrating factor is 1 by x cube. So if you multiply the equation with 1 by x cube, 1 by x plus y square by x cube into dx, this is equation, right? This one. If you multiply with 1 by x cube, this is x square by x cube is 1 by x plus y square by x cube dx minus y by x square dy is equal to 0, which is an exact differential equation. So integral of m with respect to x, treating y as constant, integral of terms which are independent of x in n with respect to dy. So the terms are 0 here in y. So this we have to integrate with respect to x. So okay. So log x plus minus 1 by 2x square into y square is equal to 6. This is what we have. This is the solution of the given differential equation. The next problem is solve 1 y into 1 plus xy. See here also this type of problems we have seen. I said function of x into y dx plus g into xy into x dy. This is in this form. See the function here, x into y and y dx. Again this function of x into y and x dy. In such case, if this equation is not exact, then 1 by mx minus ny is an integrating factor provided mx minus ny is not equal to 0. This is the principle that we have. As I said earlier, this is a big problem, let us say, finding the exactness of a differential equation, then find the integrating factor, and then multiplying the equation with integrating factor, and then finding the solution. There are 4 different steps. So again, once again, this question can be asked, I guess, test the exactness of the, is the equation exact, not exact, linear, homogeneous, so many options. If it is exact, you may be asked to find the solution. Directly integrate dx plus so on and so forth. The method is there. Okay. If it is not exact, let us say, then the question will be, if this equation is not exact, then what is the integrating factor? So options A, B, C, D. So for the integrating factor, we have one more question. So once you calculate the integrating factor, the third question can be now taken a form. It can take a form like this. If the integrating factor of so and so differential equation is, say, let us say, what is that, 2x square y square, then what is the solution of the given differential equation? Then what we do? We multiply this given equation with the integrating factor and then apply the formula for the solution, that is integral m dx plus integral terms independent of x in n with respect to dy. So the problem, complete problem, because there is a short multiple choice questions, one does not dare to give this big problem, and it will definitely trouble the students. In such case, what can be done is, if I were the examiner, what I would do is, I simply take a part of it. I give the integrating factor and ask to find the solution. Or else, if I give you that it's not exact equation, I'll ask you to find the integrating factor. So this problem, if you do the complete problem, all the 4 sub problems you will be knowing. Okay, find integrating factor, find the solution, all the things related with this. So do practice the problems. That is always better. And we don't have any other shortcut method for these problems. We have to go it completely. So another one is, here also, y cube minus 2x square y dx plus 2x y square minus x cube dy. M is so and so, n is so and so. So dou m by dou y is 3y square minus 2x square, and dou n by dou x is 2y square minus 3x square. So if you observe the terms, are they equal? No. Is the equation exact? No. So the first problem is over. If it is not exact, what is the integrating factor? What is the integrating factor for this? So clearly, this is a homogeneous equation. Degree 3 here is 2 plus 1, 3. 1 plus 2, 3, 3. Okay. We have another method here, x power alpha, y power beta plus 3 minus so and so. But it's not necessary. You can solve this problem using this method. So another thing is, y cube minus 2x square y dx plus 2xy square minus x cube into dy is equal to 0. M is y cube minus 2x square y and n is 2xy square minus x cube. Dou n by dou y is 3y square minus 2x square and dou n by dou x is 2y square minus 3x square. So clearly they are not equal, hence the equation is not exact. So here also degree of this is 3. This is 2 plus 1, 3. Here 1 plus 2, 3. Hello? Is it okay? Okay. Excuse me. Okay, okay, okay. Okay, okay. Now, okay. Now paint it better already. Okay. Okay, right. Is it coming now? Okay, is it possible? Okay, thank you. So sorry for the technical problem. So this is what we mean linear equations and the constant coefficients. So higher order differential equations means the higher order derivative is not first order first degree equations. We were dealing with higher order derivatives dn by dxn, dn minus 1 by y by dxn minus 1, dn minus 2 y by dxn minus 2, so on and so forth. K and y is equal to q of x. The terms here is k1, k2, k3, kn are constants. There are simple constants. That's why this equation is called higher order linear differential equations with constant coefficients. First, you have to understand the structure of the equation. The terms that are available or that are involved in this equation. So this k1, k2, k3, kn are constants, and this is a higher order derivative. So qx is a function of x. That is the standard structure of the higher order differential equation with constant coefficients. So here, general notation that we follow is dy stands for dy by dx, d square y is d square y by dx square, dny is dny by dx, and that is nth derivative. So then this equation can be expressed now as dn, that means nth derivative, plus k1 dn minus 1, so on and so forth. The last one is kn y is equal to qx. So if you see this term here in the bracket, d power n plus k1 dn minus 1 plus k2 dn minus 2, so on so kn, it looks like a polynomial in d. It's like a polynomial in d. So we represent that by f of d. F of d. So in a nutshell, this equation can be simply expressed as f of d on y is equal to q of x, where f of d is d power n plus k dn minus 1 plus k2 dn minus 1, a nth degree polynomial in a differential operator d. So they will be dealing with the equations of the form f of dy is equal to 0, is equal to q of x, where f of d is a nth degree polynomial in the differential operator d. This is the problem structure. Okay. So this is a nth order first degree linear differential equation with constant coefficient. Then how to find the solution? This is the issue. Since the order is n, the general solution in the formulation of differential equations we discussed this issue. A nth order differential equation, if you solve, you will get n arbitrary constants, the solution. Similarly, if you take a function with n arbitrary constants, and if you want to eliminate the n arbitrary constant, we have to differentiate it n times, then nth order differential equation is formulated. Both are one from the other. So the solution comes from the differential equation, and the differential equation comes from a function involving arbitrary constant. The same thing. So since order is n, the general solution contains n arbitrary constants. This is a very, very important point. This one. So for nth order differential equation, the general solution contains n arbitrary constants. It's a very, very important point you have to understand. Okay. So the complete solution contains two parts. Whenever you deal with differential equations, higher order equations, the solution contains two parts. One is called complementary function, generally we represent by y sub c, yc, and c stands for complementary function. And the second one is particular solution, yp, p stands for particular solution. So first let us discuss what is the complementary function, how we calculate complementary function. So finding complementary function, y of c. So y of c is a solution of the homogeneous equation. First thing is y of c is a solution of the homogeneous equation. What is homogeneous equation? So the equation now is f of d y is equal to qx. If you put qx is equal to 0, this equation is called homogeneous equation. So complementary solution function is a solution of the equation when phi of q of x is equal to 0. So that means y of c satisfies f dy is equal to 0. So this is important point. Now this f of d is d power n plus k1 dn minus 1 so on and so forth. Consider an algebraic equation corresponding to this f of d is equal to 0. As f of m is equal to m power n plus k1 m power n minus 1. Whatever polynomial we have f of d, you write it as f of m, we call it as an auxiliary equation. We call it as an algebraic equation or an auxiliary equation. So, because it's an nth degree polynomial, every nth degree polynomial has n roots. We know that. Okay. Now there are 2 or 3 cases here. If all the roots of this f of m is equal to 0 are real numbers and are different or distinct real roots, let us say the n roots are m1, m2, so on and so forth, mn. We have n roots and all roots are given by m1, m2, so on and so forth, mn. Then your complementary function becomes c1 e power m1x plus c2 e power m2x plus so on and so forth, cn e power mnx. So here e power m1x, e power m2x, we call it y1, y2, so on and so forth, yn. Then y1, y2, yn are all linearly independent solutions of this f of dy is equal to 0. This y1, y2, yn are linearly independent solutions of a homogeneous differential equation. The general solution is c1, y1 plus c2, y2 plus cn by n. That is the principle there. So, if all the roots of the polynomial auxiliary equations are real and distinct, then we know the complementary function. If one of the roots is a repeated root, let us say some alpha, m is equal to alpha comes twice, let us say comes r number of times, then what happens to the complementary function? The corresponding to this root m is equal to alpha, which comes r times, the corresponding complementary function is given by c1 plus c2x plus c3x cube plus so on and so forth, cr xr minus 1. So if r is equal to 1, that means it comes only once, then only c1 e power alpha x, just like this. Okay. If you say for example it comes twice, then c1 plus c2x up to c2x only, x power 2 minus 1. It comes 3 times, c1 c2 till x power 3 minus 1 2x square. So that means c1 plus c2x plus c3x square. So I think c2x square, it should be c2x square. Okay. This is mistake. Okay. Now that means example. What is it? Let us consider an example. What is the complementary function of y double dash minus 2y dash plus y is equal to 0? So this f of d is, you can write this as y double d square minus 2d plus y and y is equal to 0. Okay. So f of d is equal to d square minus 2d plus 1. The auxiliary equation is replace d by m simply. So m square minus 2m plus 1 is equal to 0. Or else this is same as m minus 1 whole square is equal to 0. So what are the roots? M is equal to 1, m is equal to 1 are the repeated roots. When the repeated roots come, this is the issue. root is e power 2x, that comes here. Okay, here root is 1, it becomes e power x. And here c1 plus c2x plus c3x square, so on and so forth, here xr minus 1. So where r is number of times the root comes. Here in this problem, it comes twice. So r is 2. So up to we get x power 2 minus 1, that is x term. c1 plus c2x into e power x. Okay. Case 3. If you have complex roots, if real roots, distant or equal roots, repeated roots, we have done. Now what happens if you have a complex root? Let us say if alpha m is equal to alpha plus I beta is a complex root of f of m is equal to 0. Then the basics of complex numbers, if alpha plus I beta is a root, then obviously alpha minus I beta is also a root of f of m is equal to 0. So your complementary function is, so m1 is e power r, m1 is alpha plus I beta, m2 is alpha minus I beta. So your complementary function is yc is c1 m1x plus c2 m2x, because you have two roots. So e power alpha plus I beta into x plus c2 e power alpha minus I beta x. You take this e power alpha x, so c1 e power I beta x plus c2 e power minus I beta x. This comfortably can be expressed as e power alpha x into c1 cos beta x plus c2 sin beta x. Okay, or else some constant c1 star c2 star, there may be small change there. So whenever complex root alpha plus I beta is a root, then complementary function becomes e power alpha x into c1 cos beta x plus c2 sin beta x. Okay, if it is repeated now, fourth case, if the complex roots are there, imaginary roots are we have now, and they are repeated. So again, whenever we have repeated roots, wherever there is a arbitrary constant c1, c2, c3, they will be given going on expanding. So Elliot is only c1 and c2. If it is a repeated root, they become c1 plus c2x. Again, one more repetition. That means it comes 3 times. c1 plus c2x plus c3x square plus c4 plus c5 plus c5x plus c6x square. If it comes 4 times, c1 plus c2x plus c3x square plus c4x cube, so on and so forth, c5 plus c6x plus c7x square plus c8x cube. So the arbitrary constant term here and here, it goes on increasing as the repetition of the root increases. So find general solution of y double dash plus y dash minus 2y is equal to 0. The auxiliary equation is m square plus m minus 2 is equal to 0. M square plus m minus 2 is equal to 0. The roots are m plus 2 into m minus 1 is equal to 0. If you find the roots, m plus 2 into m minus 1, so m square plus 2m minus m, that is m, 2 into minus 1 minus 1. Okay. So the roots are m is equal to minus 2 and 1. They are real numbers. Are they equal? No. Distinct roots. So the complementary function is c1 e power minus 2x plus e power c2 e power x. This is the complementary function. So solve d cube plus 3d square minus 4y is equal to 0. So auxiliary equation, first replace d by m and write the auxiliary equation. So m cube plus 3m square minus 4 is equal to 0. First root you have to just somehow find out. M is equal to 1, if you put 1 plus 3 minus 4 becomes 0. So m is equal to 1 is clearly is a root. So m minus 1, then if you go for synthetic division, m is equal to 1 is a root, so 1 comes down, 1 ones are 1, 3 plus 1 is 4, 1 4 is 4, 0 plus 4, 1 4 is 4, minus 4 gets cancelled, this still means 1 4 4. So the equation is factorizing m minus 1 into m square plus 4m plus 4. Clearly m square plus 4m plus 4 is nothing but m plus 2 whole square. M plus 2 whole square. So the roots will be m is equal to 1 is a root. M plus 2 whole square means m is equal to minus 2 minus 2. They are the roots. So this is a repeated root. This is a repeated root. This is a distinct root. So corresponding to this root, you get the complementary function, part of the complementary function c1 e power x. And for the repeated root, because it comes twice, This C2 plus C3x into e power minus 2x is a complementary function corresponding to the repeated root m is equal to minus 2. So this is your complementary function. So d cube plus 16 dy is equal to 0. The auxiliary equation is this m cube plus 16m is equal to 0. So if we take m common, this becomes m square plus 16 is equal to 0. What are the roots? M is equal to 0 is one root and m square plus 16 is equal to 0. So m square is equal to minus 16. Minus 16 means 16i square. So m will be plus or minus 4i, complex roots. So here because it is 0, C1 e power 0x, this is C1 only, e power 0 is 1, plus here in complex roots, what we have said, alpha plus I beta is a root. Alpha is the real part and beta is the imaginary part. Here what happened in this problem? Plus or minus 4i. What is alpha here? 0. Whenever alpha plus I beta is a root, we are writing the solution as e power alpha x into C1 cos beta x plus C2 sin beta x. What is beta? Imaginary part. Alpha is here like this, e power alpha x. So in our problem, alpha is 0. Alpha is 0. So this becomes e power 0x into C1 cos beta x plus C2 sin beta x. Beta is 4. So C1 cos 4x plus C2 sin 4x. So this is C1 plus, so sorry, this should be C1, C2, C3. C1 plus C2 cos 4x plus C3 sin 4x. Okay. So that's how the 3 different cases, we have 4 different cases we have in finding the complementary function. They are only, first the roots of the auxiliary equations are real and distinct. Second case, real and repeated. Third case, complex and distinct. In fourth case, complex and repeated. These are the 4 cases that we have in complementary functions. Now, particular integral. We know that D represents a differential operator. D stands for d by dx. Okay. Now, similarly, 1 by d means, see, mind you, remember this, derivative and differential operator and integral operators are inverse operators. Okay. Okay. D and 1 by d. If d represents derivative, then 1 by d represents integration. Right? So, the same sense, d represents differential operator. So, 1 by d or d inverse represents integral operator. So, we have some standard results here. So, 1 by d means 1 by d of f of x means integral of f of x. 1 by d of fx is integral of f of x. With this basic idea, there are some important results for us. 1 by d minus a q of x is equal to e power ax into q of x e power minus ax dx. It is nothing but the solution of it looks like a solution of integral linear equations. Okay, because derived from linear equations only. This expression comes from only linear solutions of linear equations. So 1 by d minus a of q of x is equal to e power ax into q of x e power minus ax dx. Say for example 1 by d minus 4 into x. If I take q of x is equal to x, what happens? Simply a is 4 here, substitute here, e power 4x integral q of x is x e power minus 4x dx. So e power 4x into x e power minus 4x by minus 4 plus uv parts. Here integrating this with uv parts or uv. So this is what we get, minus x by 4 minus 1 by 16. So similarly 1 by d of sin x is sin x integral. 1 by d stands for integral. Integral of sin x is minus cos x, excuse me. And 1 by d of cos x is sin x. So knowing this integral or inverse operator, then we come to f of dy, a general solution for this higher order linear differential equations with constant coefficients. how do we define this general solution of f of dy is equal to q of x now? So as we said earlier, in the beginning of the class, the general solution contains two parts, complementary function and particular integral. Yc is the solution of where the complementary function yc is the solution of f of dy is equal to 0, and yp is the solution of the actual equation f of dy is equal to q of x. Yp is the solution of f of dy is equal to 0. Mind you, remember, this f of dy is equal to 0 is called a homogeneous equation. And when you have q of x on the right hand side, this is called non-homogeneous equation. Okay, this is homogeneous equation, this is non-homogeneous equation. So, complementary function is the solution of homogeneous equation, and particular integral yp is called particular integral is solution of the non-homogeneous equations. We have already discussed, already learned about the complementary function. We find the auxiliary equation roots and 4 different cases. We have discussed the complementary function at length. Now, we have to learn how to find the particular integral. Before going for that, the first and foremost result for us is particular integral is defined as yp is equal to 1 by f of d operated on q of x. Here simply f of dy is equal to qx. If y represents the solution of this equation, non-homogeneous equation, call it the yp, then if you operate both sides with f inverse d, so f inverse d fd is equal to f inverse means here integral operator, fd is integral operator, differential operator, they are inverse of each other, so they becomes unity here. F inverse f becomes 1, so is equal to f inverse qx or 1 by f of d q. This is what we have. Then rules to find y of p. See, y of p depends clearly now 1 by f of d operated on q of x. 1 by f of d is given the problem. There is nothing in our hands. Q of x is any function of x. So, a particular integral, finding the particular integral clearly depends on q of x. There is an exponential function, there is a trigonometric function, whether it is a polynomial function or some other function, it depends completely on q of x. So let us start with q of x is equal to e power ax. If you start with q of x is equal to e power ax, then what happens? Y of p is 1 by f of d e power ax. By the formula, by standard this result above, yp is 1 by f of d operated on e power ax. And we are not going to the proof straight away and giving the formula so that you can directly do the problems. So then e power ax by, so this yp becomes 1 by f of d e power ax is equal to e power ax by f of a, provided fa is not equal to 0. So you have to remember this formula. Simply 1 by d f of e, 1 by d of e power ax, simply whatever a we have here, substitute this f. That is a trick. So then becomes e power ax by f of a. I repeat, e power ax and 1 by f of d. Substitute this a here in this f of d, becomes f of a. But only danger is sometimes as long as f of a is not equal to 0, we don't mind, then e power ax by f of e. If f of a not equal to 0. If f of a is 0, that means a is f of d is a polynomial, and if f of a is equal to 0 means a is a root of the polynomial. Let us say that factor, if you take that factor out of this f of d, because d is equal to a is a root, that means d minus a can be taken as a factor. So maybe it may come once, or maybe it's a factor, maybe d minus 1 whole square, d minus 2 whole square, d minus 10 whole power 10. How many times it comes, we don't know. Let us say 1 by d minus a power m times if it comes. Then f of d can be expressed as d minus a power m into phi of d. And phi of a clearly not equal to 0. Phi of a is not equal to 0. Then integral factor is, particular integral is 1 by d minus a power m phi of d e power ax. So this will be e power ax by phi of a x power m by m factorial. This is the particular integral and f of a is equal to 0. E power ax by phi of a x power m by m factorial. Okay. So particular integral of d square, do some problems. Particular integral of d square plus 4d plus 1 on y is equal to e power 2x. So particular integral is 1 by, this is f of d. This is f of d. So 1 by d square plus 4d plus 1 e power 2x is equal to e power 2x by, simply as I said, here a is 2, substitute this 2 here in this equation. What is this? By f of a. Simply substitute this a is good in this here. So e power 2x by 2 square plus 4 into 2 plus 1. So this is your solution. Very simple. And find the general solution. If you are asked to find the general solution, that means you have to find both complementary function and particular integral. For this, for the complementary function, first write the auxiliary equation m square plus 4m plus 1. So m is minus 4 plus r minus square root of b square minus 4ac by 2. Here we know that. So minus 4 plus r minus 2 root 3 by 2. Or if you cancel 2, minus 2 plus r minus square root 3. So minus 2 plus 3, minus 2 minus 3. So complementary function is c1 e power alpha x, and this is alpha and this is beta. c1 e power alpha x plus c2 e power beta x, that is a complementary function. And what is the particular integral? E power 2x by 13. So this your general solution is yc plus yp. Then find 1 by d square plus 2d plus 1 operated on e power minus x. 1 by d square plus 2d plus 1 operated on e power minus x. F of d is d square plus 2d plus 1. That means d plus 1 whole square. So f of minus 1 is 0. F of minus 1 is 0. So that means this you have to use this now. E power ax by phi of a x power m by m. Here phi of a is this, f of d is completely expressed as d minus 1 whole square. So phi of d becomes 1 here in this problem. Then x power m by m factor. What is m? How many times this factor is repeating? This root is coming. Okay. X power m by m factorial. So here this f of d is d plus 1 whole square into phi of d is 1. Nothing, we have phi of d is 1. So phi of a is also 1. So x power m, how many times this factor is coming? D plus 1 whole square, m is 2. Okay. So this yp is now e power minus x power m by m factorial, x power 2 by 2 factorial. So I go back to the formula once. E power ax by phi of a into x power m by m factorial. Phi of a in our problem is 1, and this d minus a power m, the factor is coming twice, d minus a power m. In our problem it is d plus 1 power 2. So m is 2, so x square by 2 factorial. Next, find the complete solution of d square plus 5d plus 6y is equal to e power x. For the complementary function, the auxiliary equation is m square plus 5m plus 6, and if you factorize this, m plus 2 into m plus 3 is equal to 0. So roots are m is equal to minus 2 and m is equal to minus 3. So complementary function rules are real and distinct. So the complementary function becomes c1 e power minus 2x plus c2 e power minus 3x. Okay. And coming to the particular integral, e power x by 1 by f of d e power x. 1 by f of d e power x. So because e power a, this is x is e power ax, a is 1. If you substitute here e power x by 1 square plus 5 into 1 plus 6, that becomes e power x by 12. So the general solution is complementary function plus particular integral c1 e power minus 2x plus c2 e power minus 3x plus e power x by 12. Next problem. Find the particular integral of d square plus 6d plus 9y is equal to e power minus 3x. So here a is minus 3. F of d is d square plus 6d plus 9, or f of minus 3 is 9, 6 into minus 3, minus 18 plus 9, f of minus 3 is 0. So f of d is d plus 3 whole square. And what is phi of d? More terms are left, so phi of d becomes 1. So y of a is 1 by phi of a is 1 e power minus, see this is this one, okay, this is what, e power minus 3x by phi of a is 1 into, because the root comes twice here, so it becomes x power m by m factorial. Okay, this is how we get this. And then if we have exponential function, we have seen how the solution comes. Now whenever we have q of x is equal to sin alpha x or cos alpha x, in such case yp is given by 1 by f of d sin alpha x or cos alpha x. For both the functions the method is same. For both the functions, for this method is same. That means yp is 1 by f of d sin alpha x or cos alpha x. If you assume this f of d as a function of d square, let us say phi of d square. So this method, you listen carefully. So we will do so many manipulations in this to come out of this, to find a solution. So let's treat this f of d is a function of d square here. So then yp becomes 1 by phi of d square sin alpha x. By phi of d square sin alpha x. Then yp is given by, remember this formula, phi of minus alpha square into sin alpha x. Yp is 1 by phi of minus alpha square sin alpha x if phi of minus alpha square is not equal to 0. That means what we are doing, this is the formula 1 by phi of d square sin alpha x. What we are doing, we are replacing d square with minus alpha square. Replacing d square with minus alpha square. So it becomes 1 by phi of minus alpha square sin alpha x if phi of minus alpha square is not equal to 0. If phi of minus alpha a square or minus alpha square, whatever it is 0, then yp is cos alpha x by d square plus alpha square is equal to, if it is cos alpha x by 2 alpha sin alpha x. If it is sin alpha x by d square plus alpha square, this is minus x by 2a cos alpha x. So we have two formula, x by 2 alpha sin alpha x, and if it is for sin alpha, minus x by 2 alpha cos alpha x. I repeat the method here. So 1 by, we assume that f of d is a function of d square, so yp becomes 1 by phi of d square sin alpha x or cos alpha x, either for both the functions. Okay. So the particular integral becomes 1 by phi of minus alpha square sin alpha x or cos alpha x if phi of minus alpha square is not equal to 0. There is no issue at all. Simply replace d square by minus alpha square, you will get the particular integral. The problem comes when this phi of minus alpha square becomes 0, the denominator becomes 0. That is an issue. So in that case, yp becomes here, for if you consider this q of x as sin alpha x, then yp is sin alpha x by d square alpha square is equal to minus x by 2 alpha cos alpha x. If it is for cos alpha x, yp is cos alpha x by d square plus alpha square is equal to x by 2 alpha sin alpha x. These two things are very, very important. So based on this, we will deal some problems. Find yp of d square plus 2 on y is equal to cos 2x. So as usual, yp is 1 by f of d cos 2x, or consider this as f of d square, phi of d square. Anyhow, it's only d square term is there, phi of d square. And what is alpha here? Alpha is 2. Cos alpha x, alpha is 2 here. So as per rule, what we have to do is replace d square by minus alpha square, and alpha is 2, so minus alpha square becomes minus 4. So if you replace d square by minus 4, 1 by minus 4 plus 2 cos 2x, this is a particular integral. So general solution, d square plus 2y is equal to 0, find complementary function, and this is the particular integral. Similarly, another problem, find yp of d square minus 3d plus 1 on y is equal to cos 3x. So y of p is 1 by d square minus 3d plus 1 cos 3x. Here alpha is 3. Okay. So the question now is we'll treat this as a function of d square. So and then replacing d square by minus alpha square. Let us do it first. Let us see what happens. D square by minus alpha square is minus 9. So 1 by minus 9 minus 3d plus 1 cos 3x. So minus 9 plus 1 is minus 8. Very good. Then what about 3d? Is still d is there. There should not be any d's left over in this f of d. So we have to deal with this d. Okay. So for sin alpha and cos alpha, d square is replaced by minus alpha square. So you always want to have d square term in the denominator. You always try to have d square term in the denominator. Now what we have here? 3d plus 8. When you have 3d plus 8 in the denominator, you want this to be in terms of d square terms. What we can do is, if you multiply the numerator and denominator with 3d minus 8, what happens? Then the numerator 3d minus 8 divided by 3d plus 8 and 3d minus 8. So a plus b into a minus b is a square minus b square. So 9d square minus 64. Now what happened? Your d square is there in the denominator, function of d squares. Now again repeat the application. Replace d square by minus alpha square. Replace d square by minus alpha square. So minus of 9 into minus 9 minus 64. So in denominator now is free of d. We don't have any problem. But if you see in the numerator we have 8 minus 3d. Don't worry about this. What is d? Differentiation. D stands for differentiation. So 8 minus 3d cos 3x by minus 145 is d is the differential operator. So 8 into cos 3x minus 3 into d of cos 3x. D of cos 3x means derivative of cos 3x. So 8 cos 3x plus cos 3x derivative is minus 3 sin 3x. So it becomes 9 sin 3x by minus 145. This is how we deal with cos and sine functions. Let us see another problem. Y double dash plus 4y dash plus 4y is equal to sin x. Okay. Auxiliary equation is, I want the complete solution of this. So auxiliary equation is m square plus 4m plus 4 is equal to 0. Okay. So else m plus 2 whole square is 0, or m is equal to minus 2 repeated roots. When we have repeated roots, we have c1 plus c2x e power minus 2x, that is complementary function. Okay. So coming to the particular integral, 1 by d square plus 4d plus 4 operated on sin x. So what is alpha? In sin alpha x is sin x, so alpha is 1. So minus alpha square is minus 1. You replace d square with minus alpha square, so you get 1 by minus 1 plus 4d plus 4. Still in the denominator we have d terms. And d terms are not completely eliminated. So this is simplified. This is 4d plus 3 on sin x. Okay. So you need to have d square terms in denominators. For that we multiply and divide the function with 4d minus 3. So numerator we get 4d minus 3. Denominator we becomes 4d plus 3 into 4d minus 3, 16d square minus 9. Again replace d square by minus 1. So in this second step, if you replace d square by minus 1, this will be 4d minus 3 by 16 into minus 1, that is minus 16 minus 9 minus 25. The numerator 4d minus 3 operate in sine. D stands for derivative. 4 into d of sin x is derivative of sin x, 4 cos x minus 3 sin x. So 4 cos x minus 3 sin x by minus 25 is your particular integral for the given problem. So the general solution becomes complementary function c1 plus c2x e power minus 2x plus particular integral 4 cos x minus 3 sin x by minus 25. Find the solution of d square plus 4 operated by y is equal to sin x plus e power 2x. So auxiliary equation y power 4 plus y power 4 plus 4 is equal to 0. So see, this is something you have to use your basics logic here. How do you find the root of this? That's an issue. So smartly you can write this as m square plus 2 whole square minus 4m square. If you expand this, what happens? M power 4 plus 4 is okay. And 2ab is 2 into 2 into m square 4m square, and subtract that. Now once you write this is in the form a square minus b square. So that is a plus b into a minus b. So m square plus 2 into 2m. So m square plus 2 minus 2m is equal to 0. So this is 0, this is 0. The first term m square plus 2m plus 2 is equal to 0, and m square minus 2m plus 2 is equal to 0. So if you find the roots for the first equation, the roots are minus 1 plus r minus I. For the second one, 1 plus r minus I. So here 2 roots, and here we have 2 roots. Total 4 roots, because it's an nth degree, nth order differential equation. As I said, we will have n roots. So for the corresponding for the first roots, e power alpha is minus 1. Here is alpha is 1. Here alpha e power alpha x, that means e power minus x. C1 cos beta x plus C2 sin beta x. Beta is 1. Alpha plus I beta. Beta is 1. Alpha is minus 1. So e power minus x, C1 cos beta x plus C2 sin beta x means C1 cos x plus C2 sin x. For this, alpha is 1, beta is 1. E power alpha x, that is alpha e power x into C3, beta is 1, cos x plus C4 sin x. So coming to the particular integral, 1 by d power 4 plus 4 sin x. So you can operate this 1 by d power 4 plus 4 separately on this and this. When you operate on sin x, same principle. This is d square whole square. D power 4 is d square square plus 4. So replace d square by minus 1. D square by minus 1 means this is d square whole square minus 1 whole square. Okay. So plus 4, and this is simply substitute this a here in this equation. So 2 power 4 plus 1. We have learned this both the methods, right? So this is your particular integral. So your complementary function becomes e power minus x c1 cos x plus this, but general solution becomes e power minus x c1 cos x plus c2 sin x plus e power x into c3 cos x plus c4 sin x plus sin x by 3 plus e power 2x by 17. This is the solution. Then when we have this is, you have to be careful with this. When we have taken the exponential functions we have done, then we have trigonometric functions sin x and cos x we have seen. Now we have polynomial functions x power k. Let us see what happens with this x power k. So particular integral is again 1 by d, 1 by f of d operated on x power k. Here how we proceed for this problem is, we try to express this f of d in the denominator as 1 plus or minus phi of d. 1 plus or minus phi of d. Okay. So once we express this 1 plus or minus phi of d, then expand 1 by 1 plus or minus phi of d in increasing powers of d. In increasing powers of d. So 1 by 1 plus or minus phi of d is 1 plus or minus phi of d whole power inverse, whole power minus 1. So this is the general idea. And mind you, while expanding this 1 by 1 plus or minus phi of d, it should be in the increasing powers of d. It should be in the increasing powers of d. The expansion should be 1, d, d square, d cube, so on and so forth. The expansion. So let us see some standard expansions that we require while doing problems. What is 1 by 1 minus d? Is same as 1 minus d power minus 1. Is 1 plus d square plus d cube, so on and so forth. If you have 1 by 1 plus d, this is 1 plus d whole inverse, is same as 1 minus d plus d square minus d cube, so on and so forth. Observe the terms. These 4 formula or 5 formula very important to solve problems with polynomial functions. 1 by 1 plus f d we have, this is 1 plus d whole inverse, this is 1 minus d plus d square minus d cube, so on and so forth. Other integral is 1 minus d whole square, 1 by 1 minus d whole square. This you can write as 1 minus d power minus 2. This is 1 plus 2d plus 3d square plus 4d cube, so on and so forth. And 1 by 1 plus d whole square, this is 1 minus 2d plus 1 plus 3d square minus 4d cube, so on and so forth. Okay, so that still we have two or three methods we have, and I don't want to start these methods right now because we don't have, still we have, I suppose we have 15-20 minutes time. For the problems, this time is not enough. So till now, what all we have done, we will do some more, discuss some more problems, so that this will be consolidated till now. So, if we complete tomorrow, we will complete those 3 methods, and with that, differential equations will complete, and then we'll go to the next topic. Most probably numerical methods will go to in the next class. So we have another 20-24 problems in this this thing. I'll increase the screen. See these problems carefully. What is the order of the differential equation? Clearly, order of the differential equation means the highest derivative that is available, that is d cube by dx should be. What is the highest derivative? It's a third order derivative. So order of the equation is 3. And what is the degree of the differential equation? What is the degree of differential equation? If you go back to the basics, degree of definition of degree of differential equation, it is the highest degree of the highest derivative after the radicals and fractions are removed from the derivative terms. So here 3 by 2 is a fractional radical, we have called this, and the highest derivative d square is here, d square is also here. So here the whole power 3 by 2 is here, degree, this degree is 1. So which one is correct? So to avoid that, we have to eliminate this equation from the fractions and radicals. So square on both sides. If you square on both sides, this becomes d square by y. Okay. This equation becomes y double dash plus y dash square 3 by 2. Let us see. Okay. The equation is y double dash plus y dash power 3 by 2 is equal to sum a into y double dash. This is what we have. Okay. Isn't it anything else? Yeah, a into d square by dx square. Yeah. So you have to eliminate the radicals, means square both sides. This becomes y double dash plus y dash whole cube is equal to a square y double dash square. So now find the highest derivative term. This is the highest derivative term. So this is the highest derivative term. And on the right hand side also we have highest derivative term. And what is the highest derivative? Highest derivative. If you expand this power cube, so you will get y double dash cube plus so on and so forth. Other side you have a square by double dash square. So highest degree is 3. So with these problems of finding degrees, be very careful. This degree of the problem is differential equation is 3. Okay. A problem with this. What happened to this cursor? Okay. And when the solution of differential equation dy by dx plus y by x is equal to x square. So it's again linear equation. Integrating factor dy by dx plus y by x is equal to x square. It's a linear equation with p of x is equal to 1 by x. So integrating factor is e power integral p dx. So this is e power 1 by x dx. So e power log x, or this is x. So this is solution becomes, what is the solution? When integrating factor is given to you, y into integrating factor. Previous lesson was there online. Okay, please check it. Okay. So what define a homogeneous differential equation is a theoretical question. We need not worry about this. What are the differential equations satisfying the relation? This type of questions will not be there. You can delete also from this. But the differential equation satisfying relation a x is equal to a into cos mt minus alpha. That means you have to formulate the differential equation because a and m are to be eliminated. I think we have done this problem in the class because two constants we have to twice differentiate twice. The x dash is and x double dash, you will get the relation. What is the general solution of y dx minus x dy by d square? It is in the standard formula derivative of x by y. What is derivative of x by y? Y into dx minus x divided by y square is equal to 0. So derivative of x by y is equal to 0. So x by y becomes constant. That's the general solution. Find the general solution of 1 plus x square y dy minus 1 plus y square dx is equal to 0. Simply here 1 plus x square terms are there, 1 plus y square terms are there. If you variable separable method, this becomes dy by 1 plus y square minus dx by 1 plus x square is equal to 0, or tan inverse y minus tan inverse x is equal to constant. That is the solution. And what is the integrating factor? For x dy by dx minus y is equal to 2x square quotient x. As I said, for equations of the form, first let this dy by dx have quotient 1. So for that you divide throughout by x. So dy by dx minus y by x is equal to 2x quotient 2x. Then e power, what is the px here? Minus 1 by x. Minus 1 by x is the px. So integrating factor is e power minus 1 by x. That becomes 1 by x. And what is integrating factor of 1 minus x square y plus xy is equal to ax. Okay, this should be y dash. This is y dash. So 1 minus x square y dash plus xy is equal to ax. So divide with 1 minus x square. So y dash plus x by 1 minus x square. That is your p of x. X by 1 minus x square. So integral e power integral x by 1 minus x square. That is your integrating factor. What is integrating factor of xy dash plus y is equal to log x? Xy dash plus xy is equal to log x. If you observe this derivative of x into y is equal to log x. So if the integrating factor of y dash plus y by x is equal to sin x plus e power, whatever you have on the right hand side does not matter when they ask an integrating factor for the integrating factor. Don't worry about this function on the right hand side. He is asking only integrating factor only. So you have to worry about this function only. What is p of x here? 1 by x. 1 by x. And then what is the solution also that he has asked. Then y into f of xy dx plus x into g of xy dy is equal to 0. Okay. Then what is the integrating factor for this type of problems? We have already done. We have discussed this issue. 2x plus 3y plus 5 dy plus 3x plus ay plus 2 dx is exact. Then find the value of a. So this is a type of problems that also sometimes you may get. So m dx plus n dy is equal to 0. What is m? 3x plus ay plus 2. What is n? 2x plus 3y plus 5. What is dou m by dou y? A. It must be equal to dou n by dou x. What is dou n by dou x? 2. So a is equal to 2. Then this equation is exact. So this is a's value of a. Find the function which converts y dash plus y e power x is equal to 2x e power 2x into linear form. See, don't get worried when you see this problem. You don't find any this function which converts a linear equation into exact derivative is called integrating factor. What you have to find is the integrating factor here only. Okay. Solve x dy by dx plus y is equal to x cube y power 6. So if you divide throughout by x first, dy by dx plus y by x is equal to x square y power 6. It looks like a linear but not a linear equation. Why? Here y power 6 is there. So this equation is called Bernoulli's equation. What we do for this? You divide with y power 6. Then y power 6, y power minus 6 divided by dx. Okay, y power minus 5 by x is equal to x square. Then you know how to do with Bernoulli's equation we have discussed. Then comes x cube plus secant square y dy by dx plus 3x square tan y is equal to cos x. So it should not be there. This also is somewhat reducible to Bernoulli's form. So first divide through by x cube, you will have some clarity. So if you divide through by x cube, this becomes secant square y dy by dx plus 3x square by x cube, that is 3 by x tan y is equal to cos x. Here we have tan x term here and we have secant square term here. What is the relation between tan and secant? Derivative. What is the derivative of tan y? Secant square. Then if you put tan y is equal to secant x, tan y is equal to t. Okay. Then what happens? Secant square y dy by dx becomes dt. Okay. Then the equation becomes t dash plus 3 by x into t is equal to cos x. So this is in the form linear form. You put tan y is equal to t, secant square y dy by dx becomes dt by dx. Replace this by dt by dx, this term by dt by dx, okay, and this by t. This becomes a linear differential equation. Now solve x dx plus y dy by a square into x dy minus y dx by x square plus y square. On the right hand side, if you multiply and divide by with 2, 2x dx plus 2y dy, it is derivative of x square plus y square. We have divided with 2, so half derivative of x square plus y square, and on this side this is tan inverse x by y. So a square into tan inverse x by y. So if you integrate, x 1 by 2 x square plus y square is equal to tan inverse y by x. This is what we get. So this one is 5x power 4 plus 3x square y square minus 2xy cube dx plus 2x cube y minus 3x square y square minus 5y power 4y dy is equal to 0. To solve this, first is in the form m dx plus n dy is equal to 0. First check for the exactness. Dou m by dou y is equal to dou n by dou x. If it is exact, integral m dx plus n dy is equal to constant. Integral m dx plus integral terms independent of x in n with respect to y is equal to continuous solution. Check it for the exactness. If it is not exact, then you have to find the integrating factor. What formula should be applied here? That is the most important thing in exact equations. Reducibility exact form. So for that it is very clear. X power 4 degree is 4 here. The second term 2 plus 2 4. This is 1 plus 3 4. So here throughout degree is 4. What about this? 3 plus 1 4. 2 plus 2 4 and 4. And this also is of degree 4. So homogeneous equation, and then check mx plus ny is not equal to 0 or not. If mx plus ny is not equal to 0, so 1 by mx plus ny is your integrating factor. Solve 3y plus 2x plus 4 dx minus 4x plus 6y plus 5 is dy is equal to 0. This is also mdx plus ndx form. So dou m by dou y is 3 and dou n by dou x is minus 4. So it is not exact, they are not equal, so it's not exact. Then find the integrating factor. Then solve 2xy dy minus x square y square plus x square plus y square plus 1 dx. So, and this also you can similarly use our exact differential equations. Find dou m by dou y is minus 2y, dou n by dou x is 2y, minus 2y and 2y by, so that becomes I suppose my minus nx by n, that becomes 1 by 2x. So that will be your integrating factor, integral 1 by e power 1 by 2x. So this problem we have done this, the function of x into y, function of x into y. So mdx plus n dy is in the form function of x into y dx plus g of xy to x dy. In such case, 1 by mx minus n, we have seen this problem also in the last class. So dy by dx is equal to y cube plus 3x square y by x cube plus 3xy square. Cross multiply and put it in the form of mdx plus ndy. So this becomes y cube plus 3x square y into dx minus x cube plus 3xy square dy is equal to 0. So m is y cube plus 3x square y and n is x cube plus 3xy square. Find dou m by dou y and dou n by dou x. Whether see they are equal or not. I think they are equal. The equation becomes exact equation. You can straight away find the solution. Solve x e power xy plus 2y dy by dx is equal to y e power xy. So if you do, to divide first this 2 with e power xy, then I think you will get, convert this into linear form. So the last problem is solve dx x square minus y square dx is equal to xy. This is also can be solved using the exact differential equations. Now we have almost all done around 60-70 problems on differential equations today. Around 40-45 problems in my presentation, around 124 problems here in this, around 74 to 80 problems we have done on first order first degree differential equations, and I have not touched the higher order equations in problems. So tomorrow's schedule is we have 2 more methods left in higher order equations. So we have to complete one is exponential function, the mix of function, 2 methods, and x power k we have to do some problems on that. These 3 methods we have to complete, and then what is left is we have to deal with previous question papers on differential equations in GATE, that we have to still go through. So this is the schedule for tomorrow. 3 methods on higher order equations with constant coefficients, and then previous question papers on differential equations in GATE examination. With that, differential equations will come to an end tomorrow. Okay, see you. All the best.